Hi everyone! Today we'll be talking about isosceles triangles. Please remember to write the focus learning target. Given properties of isosceles triangles, I will be able to find missing side lengths, angles, etc. What are isosceles triangles? An isosceles triangle is a triangle with two congruent sides. Here is an example of an isosceles triangle. The two tick marks tell us that these sides are congruent to each other. So if you see tick marks, this tells us that the two sides are congruent. Here's another example of an isosceles triangle. This is another example. So it doesn't matter which way the triangle is facing, as long as there are two congruent sides, the triangle is an isosceles triangle. So for the first few examples, we're going to use the idea that an isosceles triangle has two congruent sides. For your examples, please remember to write the problem down and also the triangle. Here, triangle ABC is an isosceles triangle. We're going to find the value of x. The tick marks tell us that side AB is congruent to side AC. These two sides are congruent to each other. So again, side AB is congruent to side AC. This means that they have the same length. So the side length of AB equals the side length of AC. Let's replace these with the given side lengths. Side AB is x and side AC is 10. So we've found the value of x. X equals 10. Let's look at another example. Here, triangle DEF is an isosceles triangle. Once again, we are asked to find the value of x. Please make sure to draw the triangle as accurately as possible. Here, the tick marks tell us that side FD and side FE are congruent to each other. So side FD is congruent to side FE. This means that they share the same side length. So the side length of side FD is equal to the side length of side FE. Side FD measures as x plus 2, and side FE measures as 12. From here, we're going to find the value of x. To do so, we're going to subtract by 2 on both sides to isolate the x. X equals 10. In this example, once again, we use the fact that an isosceles triangle has two congruent sides. Here's another example. Triangle GHI is an isosceles triangle. We're going to find the value of x. So based on the tick marks, I know that side IG is congruent to side IH. So these two sides, sides IG and IH, are congruent to each other. This means that they share the same side length. Their side lengths are equal to each other. The length of side IG is x minus 8, and the length of side IH is 11. To solve for x, let's add 8 on both sides. This cancels out, and we're left with x equals 11 plus 8, which is 19. So we were able to find the missing value of x by using properties of isosceles triangles. Next, let's look at the idea of base angles of isosceles triangles. The base angles of an isosceles triangle are the angles opposite the congruent sides. For example, here's an isosceles triangle. We know that this is an isosceles triangle because the tick marks tell us that the two sides are congruent to each other. These two angles are the base angles. Notice how these base angles are across from the congruent sides. An important property of base angles is that they are congruent to each other. So base angles are also congruent. Let's use this property to solve a few more examples. For our first example for this section, we're given triangle ABC, which is an isosceles triangle. Now we're focusing on the angles and not the side lengths. We're going to find the value of x. In this triangle, the base angles are angle B and angle C. We know that base angles are congruent to each other. So I know that angle B is congruent to angle C, which means that they must share the same angle measure. So I know that the measure of angle B equals the measure of angle C. The measure of angle B in this example is x, and the measure of angle C is 67 degrees. We've solved for x. X equals 67 degrees. Let's look at another example. Triangle JKL is an isosceles triangle. We're going to find the value of x. First, go ahead and identify the base angles. Press play when you're ready. Here, angle K and angle J are the base angles. So these two angles are the base angles. Notice how angle L is not a base angle. So just because you see an X, it does not mean that it's a base angle. So we know that base angles are congruent, so angle J is congruent to angle K. That means they have the same angle measure. Since angle K measures 50 degrees, I know that angle J also measures 50 degrees. Now what can we do to solve for x? A few lessons ago, we talked about the interior angles of a triangle. We know that the sum of interior angles of a triangle is 180 degrees. So if we add all three angles together, we will have 180 degrees. Let's use this idea to solve for x. So I know that the measure of angle J plus the measure of angle K plus the measure of angle L equals 180 degrees because they are interior angles of a triangle. We know that the measure of angle J is 50 degrees. The measure of angle K is also 50 degrees, and the measure of angle L is x. Now let's simplify this by combining 50 plus 50. This is 100 degrees plus x equals 180 degrees. To isolate x, we're going to subtract both sides by 100 degrees. This cancels out, and we find that x equals 80 degrees. So in this case, we use the idea of base angles as well as the fact that the interior angles of a triangle add up to 180 degrees. So just because you see an x, do not automatically think that it's a base angle. For example 3, triangle MNO is an isosceles triangle. Go ahead and try this example on your own, and then press play when you're ready to compare answers. Our base angles are angle O and angle N. Notice how angle M is not a base angle. Since base angles are congruent to each other, and we're given that the measure of angle O is 45 degrees, the measure of angle N must also be 45 degrees. From here, let's use the fact that the three interior angles will sum to 180 degrees. So the measure of angle M plus the measure of angle N plus the measure of angle O equals 180 degrees. We know that the measure of angle M is x, and the other two angles, the base angles, each measure 45 degrees. Set this equal to 180 degrees. Let's simplify this by adding 45 degrees plus 45 degrees. That's 90 degrees. From here, to solve for x, let's subtract 90 degrees on both sides. 180 minus 90 equals 90, so x equals 90 degrees. For here, the value of x is 90 degrees. Remember, if you ever need more time processing the information, you can always pause the video and rewind as necessary. Here's our fourth example for this topic. Here, triangle PQR is an isosceles triangle. We're going to find the value of x. Like we've done in the previous examples, let's first identify the base angles. In this example, angle R and angle Q are the base angles, so we know that these two angles are congruent to each other. Angle Q is congruent to angle R, so we know that they share the same angle measure. Since the measure of angle R is x, we know that the measure of angle Q is also x. Now let's use the idea that the three interior angles will sum to 180 degrees. So these three interior angles sum to 180 degrees. The measure of angle P is 70 degrees, and the two base angles each measure x. To simplify, we can combine like terms. X plus x equals 2x. So we have 70 degrees plus 2x equals 180 degrees. We want to isolate x. First, we'll subtract by 70 degrees on both sides. We're left with 2x equals 110 degrees. Let's divide both sides by 2. This crosses out, and I've found that x equals 55 degrees. So this example was a little different from the earlier examples because both of our base angles measured as x degrees. Here's the last example for today's lesson. Triangle BCD is an isosceles triangle. Find the value of x. This example is very similar to our earlier example, so please feel free to try this on your own first and then press play when you're ready to compare answers. Our base angles are angle C and angle D. We know that these two angles are congruent to each other. So angle C is congruent to angle D, which means they share the same angle measure. That means that the measure of angle D is also x. From here, let's use the fact that the three interior angles will sum to 180 degrees. So the measure of angle B plus the measure of angle C plus the measure of angle D equals 180 degrees. The measure of angle B is 30 degrees, and each base angle measures as x. Let's simplify this by combining like terms. X plus x is 2x. And then next, we want to isolate x step by step. We subtract by 30 degrees on both sides, and we have 2x equals 150 degrees. Next, we'll divide both sides by 2, and we are left with x equals 75 degrees. So here, once again, we use the fact that the base angles of an isosceles triangle are congruent to each other. So today, we talked about isosceles triangles. An isosceles triangle is a triangle with two congruent sides. And the base angles of an isosceles triangle are also congruent to each other. So we have two congruent sides and also two congruent angles. Great job today, and please remember to submit your notes on Canvas. Thank you.